In the IPv4 era, ARP was the trusted messenger of every local network. In IPv6, that dusty old book gets shelved forever, replaced by a sleek new protocol called Neighbor Discovery. ARP had serious problems. It flooded every device on the segment with broadcast storms, had zero built-in security, spoke only IPv4, and could not find routers, leaving networks noisy, vulnerable, and inefficient. NDP fixes all of this. It runs on ICMPv6, uses efficient multicast instead of broadcast, and operates through 5 message types: router solicitation, router advertisement, neighbor solicitation, neighbor advertisement, and redirect. Every IPv6 interface auto-generates a link local address in the FA80:10 range, built by flipping bit 6 of its MAC address and inserting FFFE in the middle, a scope that never leaves the local segment and is used only for NDP traffic. When a host boots up, it shouts, "Any routers here?" by sending a router solicitation to the All Routers multicast group FF02. 2. Every router on the segment replies with a router advertisement to FF02. 1. Delivering the prefix, lifetime, and default gateway. 4. Address resolution. NDP replaces ARP's broadcast shout with a targeted neighbor solicitation to a solicited node multicast address. The host replies with a neighbor advertisement, and the result is stored in the neighbor cache. Smarter, quieter, and built for scale. Welcome. We're going to inspect IPv6 link local addresses on this Linux system. First, clear wipes the screen so each command's output stands on its own, giving us a clean workspace for the demonstration. IP-6 address show lists every IPv6 address on every interface. Notice the FA80:10 addresses on EMP0S3 and WLAN0. Those are the link local addresses we came here to find, scoped to the local segment only. Now IP-6 route show reveals the routing table, and the key entry here is FA80:64 dev EMP0S3 proto kernel metric 256. That confirms the kernel knows about the link local prefix and routes it directly out the interface, never through a gateway. IP-6 neigh show dumps the IPv6 neighbor cache, the IPv6 equivalent of the ARP table. We see link local peers the kernel has recently talked to, including a router at FA80:1 reachable on EMP0S3. The short form IP-6 neigh is identical to IP-6 neigh show. Modern IP commands default the subcommand to show. So one last time, the FA80:10 link local addresses are visible on our interfaces, routed directly, and resolvable through the neighbor cache. Think of the neighbor cache as your personal phone book for the local network. Instead of broadcasting shouts across the room like the old ARP table, every node keeps a quiet mapping of IPv6 addresses to MAC addresses, ready to look up the moment it needs to send a frame. Every entry in that phone book lives in one of 5 states, and the state tells the node how much it trusts the mapping. Incomplete means an NS was just sent and we're waiting. Reachable means the mapping was confirmed within the last 30 seconds. Stale means we used it recently but never got fresh confirmation. Delay gives a short grace period before we re-verify, and probe actively retransmits solicitations to rebuild trust. Now let's trace a router solicitation from boot. The host powers on, constructs an RS packet, sets the destination to FF02, the All Routers multicast group, and sources it from its own link local address. Every router on the link hears the RS, processes the request, and replies with a router advertisement packed with a prefix information option carrying prefix length, valid lifetime, and preferred lifetime, plus the MTU, hop limit, and the M and O flags. Not every host needs that exchange. A link local only device, one that only talks to neighbors on its own segment and never reaches beyond, has no reason to install a default route, so it skips RS entirely and stays self-sufficient. Contrast that with a full internet-connected host, which depends on the RS and RA handshake to learn its default gateway, and the prefixes it can use for global communication. Welcome to a short walkthrough on IPv6 inspection in Linux. We'll run 5 commands one at a time to inspect IPv6 addresses, the routing table, the neighbor cache, and finally verify loopback connectivity using ICMPv6. Open a terminal and follow along. We start with clear to give us a clean workspace. Clearing the terminal is purely cosmetic but standard practice before a recorded demonstration, so that each command's output is easy to read on screen without scrolling past previous clutter. Now we run IP-6 address show to list every IPv6 address bound to the system's network interfaces. The output shows low with its link local :1/128 and F0 with its link local FA80. A00:27FF, February 2:3C4D/64, and a global 2001, DB8. A00:27FF, February 2:3C4D/64, confirming the interface is dual stack ready. Next, IP-6 route show displays the IPv6 routing table. We see the loopback route :1 devlo, the link local FE80, /64 deveth0, a global route via the upstream router 2001, DB8, /64 deveth0 protokernel metric 256, and the multicast route FF00, /8 deveth0. This tells us all IPv6 traffic is routed locally except for the default path. Now IP-6 neigh show reveals the IPv6 neighbor cache, which is the IPv6 equivalent of the ARP table. The entry FE80, A00:27FF, FE8A, 1C23 deveth0 ladder 52:54:00:8A, 1C. 23 router reachable confirms our default gateway has been resolved to its link layer MAC address. And the router flag tells the kernel this peer is advertising itself as an IPv6 router. Finally, we verify ICMPv6 loopback by pinging the :1 address with ping 6. 1C3. 3 replies come back from :1 with an ICMP_seek of 1, 2 and 3 and times under 1 millisecond, ending with a clean summary. 3 packets transmitted, 3 received, 0% packet loss. This confirms the IPv6 stack is fully functional end-to-end.